Hello and welcome to the final series lecture of Introduction to R. Now, previously, we had already talked about how to install R and R Studio in your device. We had also gone through a very few basic commands regarding the calculations, plotting graphs from different datasets, and also using various formulas to draw mathematical and statistical functions. Then, on the previous video, we had talked about how to add customization to the normal generic graphs. So today we are going to continue on that particular topic, this customization of plotting and interactive visualizations. However, today we are going to specifically use now for bar charts and histograms. So let me share the screen. So this is our RStudio window where we are going to use the bar charts today and histogram as well. And we're also going to see how both of them can be easily customized in RStudio. So on the previous videos, we had mainly used the dataset iris and used various kinds of techniques and package plottings to give us various different outputs. Today, we're going to use a different dataset. So let's say initially we are going to write library datasets, even though I personally do not need to write this because my base package is already active. But always remember when you are trying to open RStudio for the first time and you are using the first command of a program, you can always use library datasets. It's a good habit to always write this and execute it even before you do anything so that your base packages are refreshed. So now let's say we're going to do the visualizations. Now in the previous videos, we had done basic plots. We had always given the term plot whenever we are trying to get a visualization output, and R Studio has itself decided what kind of plot it wants to do for the specific data it had. Today now, we're no more going to give R the option, but we're going to choose ourselves what kind of graph or what kind of visualization we need to gather from the dataset. So let's say we're going to start with bar charts. Now, bar charts is a specific type of charts, and it is one of the most basic graphics where any kind of numerical data can be used. So let's say I am loading a new dataset today, which is called empty cars. As you can see, the empty cars dataset, if you want to get more information about it, instead of executing this program, I'm using the help command, that is help on the dataset empty cars. So if I execute only line number 4, that is if I keep the cursor in this particular line and execute it, I'm going to get a detailed information about what this particular dataset is all about. So it contains all the data of motor trend car road tests. Fine. So if I want to simply load empty cars data in our global environment, I need to execute this particular line, that is line number 3. So see, now the empty cars data is now available in our global environment, and it is showing a summary of 32 observations of 11 variables. So if you want to see, we can either write view empty cars. We can either execute this particular line or we can simply click here and we're going to get the same result. That is, there are 32 different observations and there are 11 different variables containing all the different parameters that are supposed to be present in testing cars. If you want to get a quick summary of it, we can simply use the summary command of empty cars and we're going to get the 11 different variables and all of their basic summaries. Minima, first quadrant, median, mean, third quadrant, and maximum value. But today we're not going to look on this, so let's clear this particular console window. We're mainly looking for plotting bar charts. So if I give the generic command of plot, RStudio is going to take its own liberty and use that particular plot which suits this particular dataset the best. But let's say I want to only plot a specific type of graph, that is bar charts or bar plots. So for that particular case, what we need to do is Let's say I want to do a bar plot itself. Only a bar plot. Now a bar plot of what? This particular data set. Now first what we're attempting is trying to do a bar plot of the entire data set. But as we can see, there are 11 different variables. So if I try to do a bar plot of the entire data set, see, it is showing one of the variables must be a vector or a matrix. That is, for a bar plot to be happening, some of the variables need to be a vector or a matrix. But if we check the empty cars variable probably, so which particular variable it is showing? Height. In height, there are no vector or matrix elements present. So what we can infer from here is, if we try to do a bar plot on direct empty cards, it is not going to show all of the values together. However, instead of this, if you wanted to simply plot empty cards, see, our studio itself devised what kind of plot is the best for it. So it was going to do a scatter plot matrix just like the previous data sets, and where all of the variables were present in the diagonal and all of the respective scatter plots were provided in the rows and elements. But this was when we were using the plot command, right? This is where we do not get to choose the type of graph, but our studio itself decides what kind of graph it is going to allocate based on the type of data. But on this particular line, bar plot, we're trying to force our studio to do a bar plot only on the empty cars data. But however, such particular graph is not possible if there are no vector or matrix elements. So our entire bar plot of the empty cars dataset may not be possible. However, not all of the variables are missing vector or matrix elements. So what we can do is we can specifically plot one of the variables of the empty cars dataset and use bar plot on that particular command as well. So instead of doing this, if I want to give a bar plot command on which particular dataset, empty cars, and let's say I am choosing one more variable. So for choosing a variable, I will be giving the assignment operator, right? Let's say I'm choosing one of the values as cylinder. Now we do not yet know that the cylinder value contains a vector or matrix elements or not. So let's say I'm first just attempting to run this particular command. So when I'm doing so, I'm getting a histogram. But what we're trying to do was to create a bar plot, right? So to create a bar plot, even if you're giving the command as bar plot, what R is trying to do is, since some of the elements must be missing here, that's why it is already converting it into a histogram. So directly, even if you try to plot a cylinder of the empty cast dataset as a bar plot, R is, even though it is showing a graph, it is not exactly what we are looking for. So for that particular reason, what do we need to do is we need to convert this particular variable into a table or in a matrix format. So for that, let's say I am giving a new name. This particular variable is cylinders, right? So let's say I am assigning a completely new variable, cylinders. Now I am assigning it to as a table or in a tabular format. Now table of what? Table of the data set, and which between which we're highlighting that particular variable as well. So what we're doing here, the difference between line 7 and line 8 was, in line 7, we were directly trying to highlight the cylinder variable from the empty cast dataset and try to create a bar plot. But as you can see, the bar plot was not coming out perfectly. So what we're doing is we're converting this entire part, the dataset, and highlighting the variable. We're now converting it into a table, and now we're assigning this particular table into a new variable called as cylinder. So once I execute this command, see, we're getting a new dataset in our global variable. So, but see, this particular cylinders is neither based nor contributed. We are creating, this is our own creation. We have created a new dataset cylinders based on the tabular values of our already established dataset empty cars. So now cylinders contain the tabular values of empty cars and cylinder values together. So now if I want to do a bar plot of which particular variable do we need to choose? The cylinder value, because the cylinders already contain the tabular of empty cars and cylinder. So now we want to do a bar plot of cylinders itself. So now if we want to plot it here, so now we're going to get a proper bar plot or a proper bar chart. However, if we wanted to get a default line chart or an XY plot, instead of bar plot, we could have given a simple plot. If we want to do a simple plot of this tabular value only, we're going to get a normal line chart or XY plot because none of these values are actually represented in how we want to. Since we gave the plot command, R decided that this was the best type of graph on that particular data. However, we fooled R into thinking that a table was created. However, the table was created from that particular data, which did not contain any vector or matrix values. So we fooled R into thinking that we have created a compatible table, and when we tried to plot that table using the bar plot, we got our desired result. So this is how we can draw bar charts in RStudio, even when the dataset does not actually support creation of proper bar charts. Next up is histogram. Just like bar charts, histograms are also very important whenever we're going to get some visual interactions about the datasets. Now, on histograms, we mainly see the shapes, the gaps, the outliers, and the symmetry. All of them together give us an idea about the dataset and its distribution in that particular range, or whatever the starting value and the ending value, the boundaries that we are providing it. So let's say we want to create a histogram only. So once again, we are referring back to our original dataset iris. So to do so, I need to load the iris dataset first. At this moment, it is not loaded in our global environment. We only have the empty cast dataset which we previously loaded and the cylinders table value which we created out of the empty cast data. So now we are loading data iris as one more value here. Now to draw a basic histogram, instead of doing plot, we have already done this particular command, right? We have done plot, we have given the data set, we have done the assigning operator, we have chosen any one of the variables, numeric variables. And when we tried to plot it, it was coming as a scatter plot. But now we're not giving R the option to choose what the best kind of plot will be for this particular data. We're now choosing on our own that we do not want a scatter plot, we want a histogram. So the command for histogram is hist. What we are going to do is histogram, that is hist. This means that we are asking R to draw a histogram of which particular dataset? Of the dataset iris. And now we're choosing the same variable that we had chosen on the before line, that is sepal length. So the difference between line 13 and line 14 is on line 13, we just asked R to plot a graph based on the sepal length variable of the iris dataset. But here we are asking R to draw a specific type of graph or a plot or a histogram only, no other kind of graph of the same variable of the same dataset. So now if I want to plot it, see, we're going to get a histogram. See, on line number 13 and line number 14, there is only one difference. One had a plot value, now we'll have a histogram value. So whenever we are providing this particular command, his, that means R recognizes that we are asking it to plot a histogram on the required data. So this is how we can draw histograms. Now, what if we want to plot both of them graphs at the same time? If you notice it properly, whenever we're executing line number 13, our graph is changing back to the original scatter plot. And whenever we're executing line number 14, the graph is reverting back to the histogram. So if I want to plot them together, plotting them together means selecting the lines both together at the same time and then running the execution. So now if I do it, see both of them are executed, but the graph here is not changing. But even though I've selected both, that means what? Both of the plots should be here, but only one of the plots is present here because this particular plot window is only default. At default, it can show only one of the values or one of the outputs at this one time. So to change this, we use a specific type of command called PAR. This is nothing but it means partition. So consider thinking this entire graph window as one data sheet. So if I want to partition it into multiple rows and columns, then I can get different small scopes on which I can plot different types of graphs and at the same time as well. So let's say I want to partition this particular graph window and I'm doing with respect to row. Fine. Now, in how many rows and columns I want to partition this particular graph, that is solely dependent upon me. So this C stands for concatenate or combine. So on how many different rows and columns I want to separate this particular graph plot. So let's say I want to choose 3 rows and 1 columns. This means this entire graph set, which is now one sheet, will now be divided into 3 rows, 3 different rows, and only 1 column. So I'm not changing the column at all, but what I'm doing is I'm assigning this one particular data graph sheet to 3 different rows, which will be divided among between the 3 different graphs. So once I execute this program, nothing visually changes, but this particular sheet has now already been divided into 3 different rows. So after I have already partitioned into 3 different rows and 1 column, now if I want to plot these two, so if I individually want to, let's say the plot the first one or which the scatter plot would come. Now if I want to plot it, see the scatter plot is now only restricted to 1/3 of the entire data sheet. Otherwise, it was supposed to come to the entire sheet only, right? But it is now coming only to up to the 1/3 data sheet. Now it's already the first row is already occupied with the scatter plot. So now on the second row, if I want to plot the second histogram, see, we're going to get the histogram. Now see, both of them together are arriving at the same space. Even though this is a scatter plot which has been plotted differently, and this is a histogram which we have generically asked our studio to plot it like this. Now both of them together are combined in the same graph panel, even though we have distributed it differently. So there is one more space left here. So let's say now I want to plot the entire dataset iris. Where it is going to come? It is going to come in the third row. And as and how? It is going to come as a scatter plot. But see, whenever we are going to do this thing, this entire dataset is now taking over the volume. This entire dataset, whenever we are going to plot an entire dataset, the entire partition is now going to get cancelled. But once again, if I simply separate it like this, see, we could have easily calculated both of them. So instead of an entire dataset, if we now provide one more value, let's say sepal length and sepal width, that is a scatter plot between these two. So whenever we're providing this particular command, even though there are multiple variables present here, but we're not trying to plot the entire data set, what it is showing? It is showing 3 different graphs in the same part panel because we initially partitioned the graph to 3 different rows and 1 column. So the column part is not changing. However, what we have done is we have distributed the graph into 3 different rows of 3 different types of graphs. Similarly, if I could have changed instead of 3, 1, if I wanted to change it to 2, 2, that means what? I would have partitioned this entire graph into 4 parts, 2 different rows and 2 different columns. Let's say I execute this one. Then I execute the first column. Now check. This belongs into the first row and the first column part of the graph. There are 3 more spaces that I can occupy using completely 3 different graphs. If I plot the second one now, it is going to take the second space. That is the first row and the second column space. Similarly, if I want to go for this one, it is going to take the third space. And also now if I want to plot a histogram of, let's say, iris, and we're going to go into try and plot the histogram of the categorical variable, that is species. Now, whenever we are trying to plot a histogram, we know that the value must be numeric. So this is why a histogram of the categorical variable is not possible. So instead of trying to do a histogram, what we can do a generic plot, that is a normal Saturn plot, which will come as a fourth species here. So we can see we would have converted the entire graph into four different parts. So the number of rows and number of columns and how many divisions we're going to divide it, it's completely up to us. Now, if you want to stop here, if you want to partition it into multiple spaces, we can simply change these values to the number of rows and number of columns. And let's say we're done with it. And let's say we only want our original graph sheet back. That is, whenever we're plotting one value, only the entire sheet will be covered with only one of the graphs. So for to do that, what we need to do is again change the parameters to, it's very easy, 1 comma 1. What does 1 comma 1 mean? Only one row and one column. That is, the entire graph is now again back to its original location. So now if I execute this command and then if I initially run this program, see, all of them are now going to take their entire data set as the total part of the graph. So we can partition the plot window like partition mf row with number of columns and number of rows. So this is one way we can plot different graphs in the graph pane at the same time. Now we can also plot different specific types of histogram. So let's say what we did right beforehand was to draw a histogram of the iris species or a categorical variable. We already know the outcome. A result will not be coming because species does not contain any numeric values. See, it is showing an error. It is showing that X must be numeric. However, if we see the iris dataset properly, even though there are categorical variables, but among each of this category, they are assigned to certain numbers in the other variables. So what if we given condition? So let's say for some particular value of the species, there will be some numbers present in the other four variables, right? So what if we want to plot a histogram with respect to those? Whenever we're going to do that, we can say that we want to plot a histogram. Now, histogram of what? The dataset. Then the variable that we want to choose. Now we can't choose species directly because it is a categorical variable, so it will again once again show an error. So first we are choosing a numerical variable. So let's say I'm choosing petal width. Fine. But now instead of doing this particular graph directly, if I plot it here now, what will happen? Only a histogram will come with respect to petal width. But now what I'm going to do is I'm going to specify which particular variable value is compatible with this petal width as well. So my initial target was to plot the iris species, a categorical variable, into a histogram format. So what I'm taking first is taking the help of a numerical value. Now corresponding to these numbers, there are some specific variables which are also contained in the categories, that is in the species value. So what I'm going to do is I'm going to go a bracket and I'm going to write iris and I'm going to choose the variable as species. Now, which particular species? If I choose species entirely, then all of the petal width will be selected. I'm going to choose only one of the species types. So let's say I'm choosing only Setosa. There are three different species types here: Setosa, versicolor, and virginica. So let's say I'm choosing only Setosa. So what am I going to write? I'm going to give a double equal to. Double equal to in R programming means a selector, or we mean it is equivalent to. So what we are mentioning here is that iris dollar species will be equivalent to, let's say, with double quotes, Setosa. This means that we are trying to plot a histogram of a categorical variable Setosa, but with respect to their values in the numerical variables. So now if I execute this command, see, we're going to get a histogram which has the Setosa values, but with respect to their petal width numbers. So this is a basic histogram plot when we are using a numeric value to plot their counterpart categorical values. But then again, this is a normal histogram. and see these, all of the titles are available here, but they are not really in a refined format. And also the color, we have not defined any customization, so the colors are very bland. So let's say I want to customize this histogram. So what I can do is, first of all, I can change its color. Let's say I'm giving the color to blue. If I execute this one, okay, the entire histogram now becomes blue. But we are not going to stop there, right? We're also going to change the labels. Let's say X label is given as setosa with respect to petal width. Setosa with respect to petal width. And we're also going to change the Y level. Let's say we're changing the level to frequency only. Okay, the Y level does not need to be changed. It's already showing frequency. So we can simply execute this particular command and our X level has been changed. What we can change is change the title of the graph. That is histogram of this entire thing now can be written as main equal to, under brackets we can write petal width for Satosa. Now if I execute this, see the main title of the graph has also changed. But here we have only customized the titles, the labels, and the colors of the histogram, right? What if I want to customize even further? There are even more parameters which we can use for changing the way the particular histogram looks. So let's say first I am going for one more customization parameter, X limit. Now, whenever I'm giving X limit, I need to give a particular range between which the X limit is going to vary. So whenever I'm going to give a range, I'm going to also have to combine the starting value and the ending value. That's why we're using a C. Now inside C, we will be defining the starting value and the ending value. So let's say I'm starting at 0 and ending at 3. So now if I combine them and execute it, what is happening here? In the histogram, only the values which were present between 0 and 3 are now appearing here. Only those values which were present between 0 and 3 are present in the graph. The rest of the values, even though they are present, they are particularly not visible because I have changed the limit of the histogram. Similarly, if I change the limit to even more, let's instead of 0, 3, I would have changed to 0, 5. Now if I want to execute it, see, changing is even further. The limit is now getting changed. I'm changing the entire limit of the X part where I'm now mentioning it starting from 0 and ending at 5. So only those values which were present between 0 and 5 are now showing. If you could see initially, the limit was very less, right? So if I change this to 0, 1, then since the values were present in decimals, many of the values which were present between 0 and 0.6 and 1, we can see none of the values are existing after 0.6, right? So most of the values which were appearing between 0 and 0.6 are appearing in the histogram. If I go on to increase the limit, these values will get condensed together. If I decrease the limit even further, that is, I want to flatten the curve even further, then histograms will be spread apart even further. But our histogram customization does not end here as well. We can also do a new customization parameter called breaks. That is the number of times we want to break the histograms into. So let's say I'm breaking the histogram into 9 different parts. And now if I want to execute it, what is this making is, it is breaking the histogram into 9 different parts. Now based on the particular range, the values are going to be changing. So we have also given the limit as 0 to 1. So instead of 0 to 1, if I would have given 0 to 3 only, that is on the previous breaks, and if the breaks was on 0 to 9. See, our entire graph is changing. We have limited the boundary of x from 0 to 3. We have broken the histogram into 9 different parts, and we have also changed the labels of the graph. But we could have done further as well. We could have used the partition command. Now, instead of 1, 1, let's say I want to do 3, 1. I execute it. Then I execute the next line. Fine. This is for petal width for Setosa. Now, what if I want to do the same thing, but instead of Setosa, I want to use versicolor and virginica. So I can copy this entire line, just pasting it here. Instead of Setosa, I am writing versicolor. Instead of blue, because it will overlap in the same color, let's say I'm doing yellow. And on the X lab, where I'm saying it's not Setosa anymore, it's versicolor. Then this is also changing to versicolor, and the main part is also changing to versicolor. So now if I plot this particular graph, see we're going to get a separate graph on the same panel, but this is with respect to petal width for versicolor. The first one was for Setosa, the second one is for versicolor. Similarly, we can do the same thing for the third type of categorical variable present in the iris dataset as well, which was virginica. So instead of blue and yellow, let's say I'm giving the color green, and this will now be next level. We're changing it to virginica with respect to petal width, and the main we're changing it to petal width for virginica, and we're just keeping the limits and the breaks as same. So now if I plot this one, see we're getting the third plot as well. So what we can see here is that we have successfully broken the entire graph panel into 3 different parts. And on the first one, we had only plotted the categorical variables which were respective to Satosa. On the second part, we had only plotted the petal width variables which were respected to versicolor. And on the third part, we're saying we've only plotted the variables which were respected to virginica. Now, see, some of the values are overlapping together because both of these values have the same position together. However, they will be needing to stop the phosphorylation, so we need to calculate all of the 3 values together. So one thing we can do is combine them, or we can plot the different graphs like this separately. Using different customizations, it's very easy to differentiate between them. And whenever we need to expand some of the histograms together, let's say I want to only expand this particular part, that is for Setosa, we are trying to decrease the limit. But for the rest, we're going to keep them as it is. So here we can see for the first one, the limit was changed 0 to 1, but for the rest, it was from 0 to 3 and 0 to 3. So the customization completely depends on how we are going to do it, what are the parameters that we need, and based on that, we can do any kinds of histogram with any color, and to make them more visually appealing, we can separate them within different parts and lock them with different parameters as well. So to clear this entire thing, or before clearing, it's a good habit to always take it to the default state. So we're changing the partition of the graph plane back to 1, 1. That is, only one of the values will now be present. That is, an entire graph plane will be taking only one graph. For example, if I want to plot this one here, say it is only taking one of the values. So this gives a basic idea about how histograms can be plotted even on using categorical variables using the help of numerical variables or on direct numerical variables. We also learned how to plot bar charts and customize them easily using some of the parameters used. So on clearing this control L, clearing this one as well. So that brings end to our lecture series of an introduction to R. Doing a quick recap, we learned about how to install R and R Studio in our devices. We learned about some of the basic program languages. What are the uses of these planes? How can we going to give an input? Where are we going to get the output? What are the different types of output we're going to have? And how we can plot some basic graphs using the dataset or by creating a data or by formula which we want to write in the input itself. We have also learned how to install different packages and how different packages help us in doing specific tasks in R. So having a basic idea about how we can write programs in R and getting different visualization outputs will definitely help in our future progress where we are going to learn even more about how R and R Studio are will be helpful for doing different types of visualization programs. Thank you.